Thank you so much. You can tell us your name and what you do here, because we would like to see exactly how the buses are charged. Yeah.
My name is Francis Mungai. Currently, I'm the head of fleet operations for Basigo. My duty is to ensure that these buses are on the road.
Okay.
We have the best uptime for the buses, as well as carry out service and maintenance for this fleet.
Yeah.
Yes.
Thank you so much. For a layman, because I know people ask themselves so many questions, what exactly is an electric bus? How is charged? I would like you to actually demonstrate to us how it's charged. You tell us how long does it take to be fully charged, how long does it take before it is charged again, and how many kilometers does it cover?
Absolutely. So for an electric bus is quite different compared to a diesel bus, given the fact that there is no fuel, and we have a set of batteries which we have to charge. For this bus is 110 kilowatt hour of battery capacity, and we have a charger here that is a 60 kilowatt capacity charger, meaning to charge this bus fully we require slightly above 2 hours, let's say 2 hours and 15 minutes to charge it from 0 to 100%. On a single charge, this bus will be able to do 250 kilometers before you can recharge it again. So those are the specs for charging this bus. Yes.
Kindly demonstrate to us. This
Absolutely.
is
My pleasure.
You can tell us what this is all about and the charging point for the bus.
This is the charging port for the bus.
Charging port?
Yes. Usually it's locked because charging an electric bus must be very intentional. So you must have a key to open and intentionally charge it. So like I said, this is a 60 kilowatt charger. It's a DC charger, because we usually have AC and DC chargers, but this one is a DC charger.
Tell us what AC is, what DC is, especially to a layman, so that unajua to understand vizuri.
Absolutely.
Yeah.
So the power that we get from the grid or from KPLC is AC power. If we had a charger on board the bus, then we'd be able to feed that power directly onto that charger, and then the charger would convert the AC into DC to feed the batteries, because the batteries can only accept DC power. But right now we are doing the conversion here. So we are feeding AC power all the way up to here. But this does the conversion now to DC, and now we feed the DC directly into the batteries.
Well understood. So show us.
So this is a charging gun. As you can see, we have
it's a gun, yeah?
Yes, it's called a charging gun. I'll plug it right in. Now it's fully in.
Yeah.
As you can see from the interface.
There's the interface here.
So that is gun B. As you can see here now, it's the bus has detected, also the charger has detected it's plugged. Gun A, which is not plugged, is idle. We have a card because the charging should be very intentional. And once we have these chargers out there, for the drivers, they're required to swipe a card and input a code, so that we can also be able to monitor which driver has accessed the charger and for which bus. And when did they start charging, and they charged for how long, and what amount of power they drew.
At the same time, is it used to pay?
Yes, for now it's not configured because it's our in-house kind of charging. But once we allow access of these chargers to other parties, then this one will be able to configure it with the cost. Yes.
And in your own assessment, is it cheaper in terms of cost compared to the diesel-powered vehicle?
Oh yes, it's cheaper by quite a significant margin of around between 20 to 30%. But even it could get cheaper, because if we get some rebates in terms of incentives from the government, and they can make EV charging rates a bit cheaper compared to the normal usage, then it can become even cheaper halfway for us to be able to adopt this technology quite fast. Also, another key point is that for us, we usually charge during the night. That's between 10 p.m. in the night and 5 a.m. in the morning. And that's the period when most of the households are not using electricity. So for us, it's a plus to KPLC because we are using the idle power, which would have been lost in terms of steam in the geothermal stations and all that. But we are uptaking that power. So if they give us good rebates and good rates for the tokens, then it will be even much cheaper to charge electric buses.
Wow.
Yeah, so once we swipe, the charger does some sequencing just to ensure that it's getting healthy power. It also communicates with the bus just to make sure that the bus is ready to uptake the power, especially the BMS part of the bus. Just seeing that it's healthy on the side of the bus and it's also healthy on the side of the incoming power from the mains. And once that is established, then it will start charging. As you can see from here, you can see that the bus is at 68%. SOC is the state of charge of the batteries in the bus. You can see the voltage that we are charging in, 591.4 volts. This is the amps we are drawing from the mains, 85.6 amps. This is the power that we are using to charge, 45.50 kilowatt. And all this information is very necessary for us to be able to compute whether we have losses within our cabling system and within the charging system, and also things like power factor and what is the rate of charging that we are using for each gun. So quite some valuable figures there for our internal computations. Basically now the bus is charging. Once the bus is full at 100%, then the charger will automatically stop the charging. So you don't need human intervention again to stop the charging. It's a safety feature that once the batteries are full, the charger will automatically cut the charging, and then you can unplug at your own time. Another safety feature is that you cannot be able to switch on the bus when the charger is plugged. That is to prevent any incidents that you can move the bus with the charger gun plugged in. So right now you cannot switch on the bus when the charger is plugged. Those are some of the safety features just to ensure that our charging sequence is not harmful to either the bus, the charger, the power, or the operator. Thank you.
Thank you. So you've seen for yourself why we need to actually embrace clean energy as a solution to especially our planet, the economy, and the people. It is cheaper compared to the diesel powered vehicles. It is more convenient. It can generate even more revenue when we talk about KPLC. So can you just conclude for yourself that this is the way to go for our planet and especially for the sake of sustainability?